Now we are coming to the talk. I think some of you will have already seen some of this all over the camp. I actually have, and I found them at EMF camp before. And I think I missed some before this. It's the PolyCoins. It's a game, and Michael Turner invented it as far as I know, and he will tell you what it is, how it works, and why he does it. Have fun.
Hi, can someone do the slides? The main screen? Or is the main screen changing? Okay, brilliant. So hopefully you have, most of you have seen this, but for the benefit of anybody who hasn't, as a bit of an overview of what the game is, it's a fictional company called PolyCoin that has this cryptocurrency. The idea is these are miners to generate that particular currency, and you capture them for your team using an RFID card. So when you first go to and visit one, it will ask you to pick a team, and once you've selected the team, everyone you visit with that RFID card will change to your team color. And the scores are based on the duration that you own it and your visits. So if you visit once or your team color, you get some bonus points. And that's the basics of the game mechanics. It's 4 teams, and you can pick from these evil corporations. So the idea originated because I played Ingress, and then I went to EMF camp and thought, well, maybe I could do something interesting. So I created this Orbs game, and the Orbs game was far more simplistic. It was literally a little ball. It could beep and make flashy lights of only 3 colors plus white. So it was quite limited in what it could do, but the basic game concept was there. And I deployed that in 2018 at EMF camp. But the Orbs game was my first attempt at this sort of thing, making custom PCB, doing all those sort of things. And it had a few problems. The cases fell apart. They were held together with stickers that I made, and yeah, that didn't work so well. There was no monitoring of the batteries, no kind of hardware monitoring at all. It had all sorts of problems with connectivity to the RFID reader, and yeah, I learned a lot from those. I also learned that ESP8266s can have random EEPROMs installed on them that aren't all the same, and sometimes they only take about 3 flashes and then stop working. So I stopped using them and switched to a slightly different model. So I wanted to make some improvements, and I wanted to go full RGB LEDs so I could play around with lots of different team colors and really make sort of the full audio so it could speak to you, really tell people what was going on, because one of the challenges was with beeps, you don't really know what it's telling you. And also wanted that full-on battery management, so it would monitor its own battery and be able to turn itself off and protect the battery, which the other one couldn't do. And I really wanted to do a better quality case, because the other ones were all falling apart. Of course, the Orbs game, that's the original one. And then I got this new toy, 3D printer, which is a dangerous thing to get. And so I thought, well, maybe I could do something a bit more interesting. So I created the new case, and I wanted it to have the nautical feel, because that was the theme EMF had for 2022. And the Polybius Biotech Underwater Deep Sea Research Lab, so I kind of went with a little bit more nautical look, and didn't need stickers. That was a really important one. So I used a few tools. I used Tinkercad to design it, because again, this was me learning how to do 3D. I'm going to progress something better, but for now, that was absolutely perfect for what I wanted to do. I used Cura to slice it, and then a Creality CR6 SE to do the printing. The case, yeah, lots of lines telling you what things are, but the main parts with this case were I wanted it to click together, so it didn't need screws and things to hold it together. So you can see where the different, that's actually, yeah, it's probably easy to point. So if you look around here, you've got little retaining holes. So you put the speaker in and then put little clips in to hold it in place. So this is the back of it. What happens is these pillars actually hold the PCB in place from the rear, so it stops it falling out of its location. And then around the edge, you have these lugs locations which mate with the same sides over here to hold it in place. And then the RFI, the antenna is actually held here, so it uses a full-sized antenna. Part of the reason for that is if you use the little traces on a campsite like this, you're not going to get very much connectivity. So I tried to make it have the best chance of good Wi-Fi signal. It also has a couple of little bits. There's a hidden power button. So if you look on the rear of them by the speaker, you'll see a little round dot, and that's actually this pillar here, which connects onto the PCB and pushes a button on the PCB to turn the unit on when it's sealed. There is no off button. You have to actually open it up or use a special method to turn it off. Up here you have the side illumination for the perspex. So that's 2 neopixels that are just in a strip there, and they get mounted up there and connected on, and they decide to illuminate the perspex disc in the middle. And around the edge is where you have a neopixel strip that has 17 LEDs on it to do all of that colourful stuff around the edge. One of the things that I learned from printing some other things was that you print a really nice, big 24-hour print, and you've got little clips on it that clip it onto something else, which is great until they snap off. And then you've got to reprint something that took over 20 hours. So what I did was I instead built these as two clips stuck together, and then they clip into the holes on each side. So that way, if I prise them apart and they snap, I just need to reprint this tiny little lug that goes in between. It also meant that whereas this is the main unit is printed sort of in layers that way, this I can print in layers this way to give it strength along the stress line. So that really helped, and I've got a bag of those just for when I snap them as I open the cases. So this is kind of an overview of the difference in the hardware. So the original Orbs game had sort of, just as I said, it bleeped PWM, and I switched to a DFR Mini DFR 0299 MP3 player because that super cheap. The memory cards cost more than the players now. It's amazing. Bigger, larger speaker, flashy LEDs. And the ESP8285, which is the same as the 8266, but the EEPROM's integrated into the expressive die, so you know you're going to get good quality EEPROM. And a PIC microprocessor, which I upgraded between the 2 different versions. So this is the PCB from one side. So up the top, we've got the 2 connections to the different LED strips, the MP3 player. Now, up on the top right is 2 micro switches, which are there to do the tamper detection. Now, the tamper detection, when triggered, causes it to flash lots of lights, make a siren sound, and scream, "Help me," repeatedly, which got very annoying for some people. So, on one occasion, I was sat at the tea tent in EMF camp, and my phone suddenly started beeping to tell me that a tamper detection trigger had gone off. And so I was like, which one? Oh, the one over there. And at the same moment, I heard a siren going off. So I kind of walked over to the hardware hacking tent, and there's a person looking quite sheepish holding this coin, making lots of noise, where they've clearly just tried to prise the back off it. So it does work. Does work. A few unfortunate incidents, though, because the tea tent actually blew over. and that triggered the tamper detection as well. And so yeah, that was a bit unfortunate, the accidental triggers. But yeah, you can see the power button just there, which is where that kind of bit that I pointed out on the previous slide touches. So when you press the case in just there, it turns it on. The other bit is the charge socket, which is a very simple USB-C power supply charger for lithium-ion cells. And obviously you've got the 3 big battery connections around the edge. The other side has far more stuff going on. So we've got a 3.3 volt power regulator. This little bit here is unpopulated, and the reason behind that is I learned that scale is really important when you're looking at the parts you're putting in if you're doing hand soldering. So I suddenly discovered that the power regulator I'd ordered was so small I could barely see it. So I kind of, but I wasn't sure I could get all the parts for a different version, so I put both on the board just in case I had problems with part supply. This, incidentally, was the 3rd, 4th power supply design I did, because I couldn't source the parts for them so many times. It was very frustrating, but I think we all know that story. You've got the Wi-Fi module up there, the PIC microprocessor sitting over there, and that's kind of the brains of the operation. That's what really does that runs the whole unit. And then you've got the RFID reader. So the RFID reader, it's a very cheap, simple one. These particular ones, they come in a really bad state from China. So the 2 lugs you can see up, sorry, the 2 inductors up here, they totally underspec them. So you get almost no reading ability in range. So what I've done is I've replaced them on all of the ones that I get. So I put ones with about 200 milliamp capability at least, and that makes them read from a fair distance and can read sort of more high energy cards like payment cards and so on, which out the box these can't do. I also removed the LED from it because it just wastes power. I don't know how much people know about RFID, but the basics are when each RFID card has a UID, which is a number between, it's either 4, 7, or 10 digits long, and is supposedly unique to that card. They are not. From the ones from China, you can get lots of duplicates, as I discovered. But the basics of the way this game works is it uses that UID to identify the player. So it queries what that is, retrieves it, and sends that off to the server for the game. There's nothing actually read from the cards during the game, particularly. The game relies purely on that UID. We don't write anything to the card to kind of identify who the user is. So yeah, this is the schematic of the board. So I hope you can all read that perfectly from where you are. So it's not intended to be looked at in detail. I can provide that, but this is the PIC microprocessor, and that, as I said, is the brains of the operation. One of the things I wanted to do was really manage the power in this, because obviously these devices are sat around flashing LEDs, doing all sorts of things for days on end, and want to make sure the batteries aren't going to run out. So power management was probably one of my highest priorities when designing this. So the reason that there's a PIC processor as well as the ESP is because the PIC processor uses only a few milliamps when it's running and can go into microamps when it's asleep. So that means that I can turn everything off and use almost no power. The ESP8266 is then used for the communications, Wi-Fi, MQTT, all of that kind of layer of comms. Rather than it being on all the time, I can just turn it on when I actually need to communicate. So one of the things that, because the PIC processor is doing a lot of communication with a lot of devices, I had to try, and it's a pretty low-powered device, I had to make sure that it could talk to lots of things simultaneously. So what I did was I used hardware offloading on everything that I could. So the PIC processor comes with hardware, 2 hardware SPI interfaces, 2 hardware UARTs. So the one UART talks to the MP3 player, one UART talks to the ESP Wi-Fi module, the SPI talks to the RFID reader, and the other SPI uses a thing called a configurable logic cell to generate it combines the output of the SPI with a PWM and a timer to generate the native signal required for the LEDs, so the WS2812s. So that way I can literally drive all of the comms in hardware interrupt driven, which means that the main program can just do its thing running sort of the game logic and not worry about any of the comms going on. So the stuff it's coded in, the ESP uses MicroPython, just because I'd use MicroPython a lot, and I'd use Python a lot, and MicroPython just made it very easy rather than having to use a different language to run on the ESP module. And I used something called Proton Pick Basic, which was just something I started with many years ago and just carried on using for my PIC programming. And it just made sense to do it that way. So one of the challenges with MicroPython, if anybody's come across this, is that because Python compiles when it runs, it's very memory hungry. If you're just trying to run code, you can get about 100 lines and then it stops because it's run out of memory on the ESP range, ESP8266. So what I do is I use a cross compiler. So you can cross compile the Py files into MPY files and copy those up to the ESP. And that allows you to run a huge amount more. I mean, I've got many times that number of lines of code, and it's running without running out of RAM. So yeah, if you do ever hit that challenge, look at the cross compiler. I've actually split things into two modules. So I have a module of functions that I kind of know work and are sitting alone, and then I have a module of the actual game sort of logic that on the MicroPython side of things. Of course, getting stuff onto the board is really kind of important. And what I've done before is I used headers, pin headers, but they're just a pain because it's a load of soldering. So instead, what I've used is pads on the PCB, so it came printed with the pads, and then I just used these to connect to it. So if on the PCB itself, there are two holes which are locator lugs. So you can see there's two kind of locator lugs sticking out on this 3D printed holder, and that causes this to be located perfectly onto the PCB. And then those pogo pins touch onto the pads so that you can then you then get a good connection. So the top one's wired up to do the ESP communication. So that just connects onto a standard USB to serial adapter that I can then cause to push the firmware, and it has a jumper on it that I can switch between pushing firmware or pushing on or connecting to the REPL. And the bottom one is a connection to the PIC 3. The PIC 3, this is not an original one. They do very cheap knockoffs these days, and yeah, it just allows me to program the PIC chips very easily on the PCB. The server runs these things. It runs on a little Raspberry Pi. It uses Python as the main code. It stores all its data in a MariaDB. I have my phone get notifications using pushover. If anybody's come across that, it's a really, really cool little tool. It allows you to call a REST API and deliver notifications to your phone or to other people's phones if they set it up as appropriate. So it's a really good way of keeping an eye on what's going on with the game. So I get alerts if disks vanish offline, when they come back online, if a tamper is triggered, and so on. It runs on, the main server is a Raspberry Pi, and all the communication is via MQTT between the different components. So when the disks boot up, they talk to the server via MQTT and kind of query what their status is and what the current config is. And that gets downloaded back to the disk via MQTT, and when you go up and present a token, it will send that request via MQTT. So kind of the sequence that when somebody goes and presents a token is it reads the RFID, checks to see if it's not the current owner of that disk, and then will turn on the Wi-Fi unit, wait for Wi-Fi to connect and MQTT to connect, and at that point it will send a query with, this is the token I've just received, and it then receives a response back with, this is a known player, this is a team they're on, or I don't know who this is. So the other thing is that because one of the challenges I had with this was disks, say, losing communication, especially the Orbs game, things would lose comms and I wouldn't know. So what I would do is with this is if they become uncaptured if it doesn't hear from the disk for a certain amount of time. So the disk's supposed to check in roughly every 5 minutes, and if it doesn't hear for about 15 minutes, then it will say, this is offline, I'm removing the owner. And it just stops disks that can't be played from just living on in the game and scoring points when no one can actually capture them. The other thing is that obviously there's a bit of security I wanted to do. You know, we're at a hacker camp. I kind of thought that maybe somebody would try. And I'm pleased to say I've not seen any alerts. Whether they've bypassed my alerts or not, I don't know. But the way I've done the communications is when the disks start up at the Wi-Fi, they actually query what the current time is. So they'll do an NTP request to get the time, and then every message they exchange includes the timestamp as they see it, and they also include some private known sort of bits of text that don't get transmitted but are included within the hash that it generates for the overall message. And then it transmits the message with the hash, which then means that the other end can verify that yes, this actually originated from a disk. So that happens in both directions. So when the server sends a message, it's signing it, and when the disk is sending a message, it's signing it, so that way they both know they're talking to each other, and it's not easy to just fake a message or replay a message because the timestamp's in there as well, and if it strays by more than a minute or two, then the system's going to reject it, and again, send me an alert that's happened. So yeah, there are some hidden features. No, actually, the hidden features, there was an EMF camp bonus, so if anybody played EMF camp, your token ID was copied over and it checked to see if you'd played before, and it would have given you a nice little welcome and some bonus points if you reused a token between the two camps. There's also something called command mode, and this was something that kind of goes back to something I said, which is it's really hard to load new config in the original Orbs game. So if I needed to change something, it was so difficult. So what I ended up doing was having a command mode that I have a control token. So this is a particular UID that it recognizes, and when you present that, it goes into command mode. At that point, you can issue various commands. One is run diagnostics, so it'll actually do some self-testing and report back if it's got any problems. It also has features such as turn it off, so I can actually turn it off without triggering tamper detection, then open the case up. Probably the most important one, though, is the ability to push new config into the device. So there's a data type called NDEF, which if you've used RFIDs before and looked at it, sometimes you'll see, if you scan it, that it will say there's certain NDEF records there. So I've basically taken a subset of NDEF and made it read the NDEF card to load the config in, so I can present new config. Unfortunately, at EMF camp, I hadn't realized a little bit of a challenge there, that the Wi-Fi had no pre-shared key. And so my idea of loading new Wi-Fi config totally failed because I hadn't accounted for being able to load no pre-shared key at all. So yeah, that was awkward. But the main thing is that I can present that, and I can cause them to re-register. So if for whatever reason they get upset with the server, they lose comms and have different keys or anything like that, I can reload the config and move straight on. The other thing was payment card identification. So there's this there's a file on payment cards called topay.sys, which when you read it, it's an open file, so you don't have to engage any form of real encryption to read it. But all it does is it contains an identifier of these are the payment card processors available on this card. So it'd be Visa or MasterCard are the principal two. What it will do is, what the game does is it reads that, and it also reads if there's a bit of text as well associated with it. So sometimes payment card providers include a few words. So it will actually read that level of detail, nothing more. But it does then prank the player. So what it will do is it will wait until you're registered, and then it will say authorizing Visa debit card donation to PolyCoin. And yeah, so this does happen. It's happened 3 times at this camp so far. It doesn't always manage to get a clear read because it requires a lot of power and more time to actually read that file. At EMF camp, there was I bumped into a guy and his little girl, and we were talking about this, and she had used her pocket money card on the reader, and she had heard it say this, and didn't hear the bit at the end where it goes, "Just kidding." So she thought that she had donated something to PolyCoin. But I think it's a good life lesson of where you put your payment cards at a hacker camp for her. So there's a scoreboard, which this is the one at EMF camp, and I'm sorry to say that the map on the one that here is still EMF because I haven't got around to updating it yet. So I will try and fix that before the end of the game if I can. But the scoreboard, it uses Pygame to render, and all it does is it sits on an MQTT feed of the scores, just looking at what those are. It draws an image of the map, and then it plots the different locations of the different disks wherever they are located, and gives you a running commentary of sort of who's winning what, how well they're doing. So there are a few problems at EMF camp. One was that. The other problem was, one was the PSK issue, but the other problem was that the Perspex disk wasn't held in so securely as it might otherwise have been, and people were pushing against it a bit, and that kind of caused things to fall apart. So I had to change the design, so I created this kind of ring halo thing that I pushed on behind the Perspex, and then had to secure with screws, which I really didn't want to do. I wanted to keep it all in plastic, but that was a way of stopping that from happening and causing it to fall apart. But aside from that, it seemed to go pretty smoothly. MCH, however, presented some new challenges. I left them in my tent on Wednesday, and the cases melted. So some of the backs of the cases kind of looked more like poppadoms than flat cases. It really wasn't good. So there were some very kind people who actually helped melt the cases back into some form of shape for me. And so this is the reason why some of them were a little bit kind of wonky. It also meant that I had to totally turn off tamper detection. So I had to reflash the firmware on all of them because the tamper detection was being triggered because the bit where the micro switch pushes against actually melted and fallen down in some of the cases. So now it was suddenly triggering where it shouldn't. So that was a challenge, and I had some very kind help with that kind of reassembly process. So the other problem I've had is that the server keeps defaulting to being turned off. For some reason, the case that I've got for my Raspberry Pi preferred to do that, and it kept also losing its USB ports on reboot. So I'm going to have to look into why it was doing that. USB boot clearly has the odd issue. A couple of special thanks. Yestin, a friend of mine, created the Node-RED website where the players register. So I know absolutely nothing about that other than it connects to our MQTT, and he did all the work on that. And Firefly for doing the fictional logos for the companies. There are still some stickers for the companies if you back at the PolyCoin HQ tent for anybody who wants some. Although I think we're out of Polybius Biotech ones now. Although I do have ones from the Orbs game, if anybody wants those. So, do we have any questions? If you just want to go to microphone.
Yes. First, thank you for the talk. And as we don't have the internet sitting here, we actually start with this microphone.
Thank you for the game. I didn't know what it was, and I did open one of them up. So yeah, I was actually wondering, because I don't think the temper detection went off, so it was off after reflashing still?
So there was at least a couple that went out before I turned the tamper detection off. So you may have just found one of those.
Yeah. Second question. The SD card was somehow write protected, I believe. How did you do that? Because
The SD card?
yes, could not write to it.
This is the speech.
Yes.
It isn't.
Weird. Okay, thank you. I wanted to write Rickroll.
Oh, right.
It didn't work. Thanks.
Hi, cool stuff. Have you considered using the PN532 chipset? Because I know those that you use and they are absolutely horrible.
Yeah, so I guess there's a little bit of history with this. When I did the Orbs game, I designed I designed it around these because they were about a quarter of the price. So, and I didn't need any of the functionality of a higher spec board. And so I just carried on that because all the libraries that I wrote for the Orbs game, I carried across into this game. And it meant that I'd have to completely start from the ground up again. And also I had a supply of these boards.
Yeah, that explains it. Also, like ESP32 PolyCoin has built-in flash and is only one chiplet and can do low power modes and has multiple cores, so radio and code don't interfere. And
Yeah, so I did look at the ESP32. The challenge I had with that is I think the low-powered core is very low-powered and couldn't do the things that I wanted it to do, which meant that I would need to run a higher power core. I could be wrong, but this was my assessment.
Might be. And also you can run the clock down on the main course and so on.
Yeah, I think it would be a challenge to achieve sort of a couple of milliamps.
Maybe.
Yeah. A lot of this, again, is down to where I had my code base, and having to rewrite everything was something I was trying to avoid, where at the same time adding the features in. Maybe there'll be a new version at some point that I'll kind of totally change everything, but
I would suggest using LoRa as the radio because the Wi-Fi is problematic always.
So I have been looking at LoRa. The biggest challenge there is the allowed on time. So you're only allowed to transmit for a certain amount of time, and that would be a problem for this game. I think I might be able to do it, but I have to really change the communication protocol, and it might still be a bit over.
Yeah, that allowed on time is actually comes from the spectrum, radio spectrum, and Wi-Fi has the same problem, but it has more bandwidth.
Yes.
Okay, thank you.
Okay.
While there's another question coming up to the microphone, I have a question. Do we have a scoreboard here somewhere?
Yes, it's at the PolyCoin HQ, which is between the Bring and Donate and the party stage.
And where do we find this HQ?
It's a blue tent. You can see a blue tent there. That's where it is. The scoreboard at the moment, unfortunately, does still show the EMF map. So I need to update it. And the color is wrong as well for Polybius Biotech, again, because it was blue at EMF and it's orange here.
Yes, so the next question from the audience.
Yeah, on one of the first slides, you talked about OTA update. So do you have that already in, or for which CPUs can you do it?
So the OTA updates works for the ESP8285 for MicroPython code that I've written. So it won't update the MicroPython itself, but it can download and update the Python scripts that are on there. I haven't done the same for the PIC chip because the flashing mechanism for that is horrendously complex. to do actually on the chip. So it's possible to do, but that wasn't my focus at this stage. It was, what can I do quickly to get the actual product working, and then I'll look to do that in the future.
Okay, so you could update the game logic, basically.
I can update certain elements of it, but the PIC chip carries a lot of the game logic, how to respond to certain presentation. Effectively, it's the bit maintaining the state of the crypto miner unit. So it knows who owns it, it knows which team it belongs to, and so on. Whereas the Wi-Fi module is literally booted up each time it wants to communicate to this game server.
Okay, thank you.
Another question from my side. At the EMF, there were these nice tokens that you also could buy and probably sponsor you by this a little bit. Do you have some for MCH? Are there some left? Can people get them?
Yes, they're still available. They're, again, in the PolyCoin HQ in a little box. There are still some of the specific MCH 2022 coins in there, if you want a memento one, and the other ones that have just got the Polybius Biotech logo on.
Cool. Is there another event where we can find the PolyCoins afterwards?
Nothing scheduled. I'll see how it goes.
Okay, so we have to be curious now to find it again and play it as much as possible at this camp because, well, we don't know when we see it again. Thank you. There are no further questions from the audience. Thank you, Michael Turner, for making this game, for telling us about the details and giving us the talk.